All right, guys, so this video is over the Unit 7 review. Okay, it has to do with graphing quadratics and all their characteristics. So let's start with the characteristics of quadratics. We can talk about the domain, which is all of the x values being used. We can talk about the range, which is all of the y values being used. Okay, we can talk about the vertex, which is the location of the highest or the lowest point. We can talk about the axis of symmetry, which the axis of symmetry, right, in this problem right here, is always going to be in the form x equals a number, because it's always going to be a vertical line. Okay, extrema is just another name for whether it's a minimum or a maximum height. So in this case, we have a minimum location. Then we're going to talk about the interval at which it increases, the interval at which it decreases, and we can also calculate rates of change, which, as you can recall, rate of change is really just that slope formula. So your rate of change is going to be y2 minus y1 over x2 minus x1 in order to make that calculation. So let's look at a few of these characteristics with the example number 1, and then you guys can try example number 2 on your own after the video. So let's talk about the domain. Okay, the domain is all of the x values. Go ahead and draw arrows on the end of this because this graph is going to continue on. Notice it's going to get wider and wider and wider as it gets higher. So we're going to end up using every x value from negative infinity all the way to positive infinity. Okay, the range is going to be limited by either the maximum or the minimum location. Notice that the lowest y value that we use is at 1, 2, 3, 4, 5, 6, 7, 8, 9. So the lowest y value is 9. And then we use every negative 9, I apologize, all the way up to positive infinity. So negative 9 to positive infinity is the range in this case. Now we can talk about the location of the vertex. Okay, the vertex is at this location right here, which is over 2 down 9. So 2 comma negative 9 is the vertex. Okay, the axis of symmetry is always going to go through the vertex. So in this case, the axis of symmetry is x equals 2. Right? Notice that is the x value of the vertex. Then we can talk about the extrema. In this case, we have a minimum. And the minimum, okay, is located at negative 9. It's the lowest value. Now we can talk about where it's increasing, where it is decreasing. Notice that we are increasing on this side, but we are decreasing on the other side. So let's write down what those intervals are. For increase, it's increasing from x is 2 all the way to positive infinity. So from when x is 2 to positive infinity, this is increasing. For decrease, it's decreasing all the way from x is negative infinity all the way to 2. All right, and then you'll try the next example on your own. If I did want to do a calculation for the rate of change, let's say I wanted to do the rate of change from x is 2 all the way to x is, 3, 4, 5. Okay, I could talk about rate of change from x is 2 to x is 5. Right, the coordinate when x is 2, that's 2 comma negative 9. The coordinate for when x is 5, that is 5 comma 0. So to calculate the rate of change between these two coordinates, we could either count the rise over the run, or we could calculate it by doing our y2 minus y1. Well, if you subtract a negative, that becomes positive. And then x2 minus x1. Right, so that gives you 9 over 3, which is 3. All right, now let's go into the next section talking about writing quadratic equations using transformations. Okay, so I want to point out that we do have this vertex form of quadratics on our formula sheet. So I'm going to jot that down and we're going to talk about all the different transformations that occur. So y equals a x minus h squared plus k. Okay. The negative, if there's a negative in front, it's going to cause a reflection across the x-axis. Okay, the number in front also is going to stretch or shrink it. So if a was 2, it'd be stretching it. If a was 1/2, it would be shrinking it. Okay, the number inside of the parentheses is going to move this left or right. Right, so left or right, where this value moves it up or down. Okay, so this is just a summary of those. Now let's try example number 3. Write an equation of a quadratic that has been reflected and shifted right 7. So keep in mind the parent function is just y equals x squared. So we're going to take this parent function and we're going to make all of these transformations occur. So y equals, if it's going to be reflected, then we need to have a negative in front. So negative, okay, parentheses, x. Now we need it to shift right 7. Okay, going right is actually subtraction and going left is actually addition. So if I wanted to go right, I'm going to have to subtract 7 squared, and it doesn't say that I'm shifting it up or down, so that would just be a plus 0 at the end. All right, go ahead and you guys can mark this one as an example for you to do after the video. Next section, we're going to talk about graphing quadratics in vertex form. Well, vertex form is what I wrote right here. Okay, but just as a reminder, you have it on your formula sheet to access the day of the EOC. Okay, the vertex is your h and your k value. Remember to take the opposite sign of h. Okay, your axis of symmetry is h itself, or more specifically, x equals h, giving you a vertical line. Okay, we can make a table in order to find more values. And we're going to start with the axis of symmetry, and then we can kind of pick 2 other points on either side of our axis of symmetry. So let's go ahead and start with identifying our vertex in this case. Okay, take the opposite sign of h, take the same sign for k. The reason why we take the opposite is because there's a built-in minus in the formula, so that's going to change it. So -7 and up 4. Here's our vertex, which we also know our axis of symmetry will go through that vertex. And this is our AOS. All right, so now we can make a table. X, comma, y. We want our vertex to go in the middle of our table, so -7, comma 4. And we are going to pick 2 points on either side. So -8, -9, -6, -5. Okay, we can turn our calculator on. We can go ahead and make a table. That is x plus 7 squared plus 4. And I'm going to start it at -5. Oops. And step is 1. Okay. So -5, comma 8, -6, comma 5, 5, and 8. Right, notice how the values repeat on either side of the vertex. So here we go. -8, that's going to be at 5. -9 will be all the way up at 8. And they should be identical on the other side. And you're done graphing. So when the video's over, feel free to try this one on your own. All right, let's flip. talk about graphing these in standard form. Standard form is written on your formula sheet. It's y equals ax squared plus bx plus c. A is in front of your x squared, b is in front of your x, and c is your constant at the end. If you want to find the axis of symmetry, we're going to do this calculation, right? Remember that the vertex lies on the axis of symmetry, so you can plug that value back in order to find the y value of the vertex. And we'll use our table feature to plot other points. So let's begin with finding the axis of symmetry. Negative b. Let's see, our a is 1, our b is -6, our c is 5. So negative b. Well, a double negative, that's going to become a +6 over 2 times a. Well, that's 6 divided by 2, which is 3. So we have our AOS, our axis of symmetry. Now we can make a table, okay, based on picking points on either side of our axis of symmetry. So we know that it's going to be 3 is in the middle of the table, 4, 5, and 2 and 1. Remember, pick 2 points on either side of your AOS or your vertex. So let's make a new table. We have x squared minus 6x plus 5. And I'm going to start my table at 1. All right, so 1, 0, 2, -3, 3, -3. Oops, sorry. 3, -4. 4, -3. And 5, 0. 1, 0, 2, -3, 3, -4, and it should just be symmetric on the other side. And then you have one to practice on your own. All right, so now let's talk about changing from vertex to standard form. Okay, so what we're going to do is we're going to have to expand the binomial. Essentially, we're going to have to FOIL the binomial after expanding. Okay, that's what the distribution is, and then we'll just combine like terms. So let's see what this process looks like. All right, let's expand. Now let's FOIL. X squared plus 2x plus 2x plus 4. Now we can combine like terms. So my final answer, f of x is equal to x squared plus 4x minus 4. All right, try the next one on your own. Okay, then we can talk about converting from standard form to vertex form. First thing that we're going to do is we are going to identify a. So in this case, a is equal to 1. Remember, a is always going to be the leading coefficient in any form, whether it's vertex or standard. Then we're going to find h, okay, by using the formula for finding the axis of symmetry, which is going to lead us to our vertex. So that is negative b over 2a. So negative b, well, b is already a -2, so a double negative creates a positive. So that's 2 divided by 2, which is 1. So I know that the x value in my vertex is 1, so that's your h. Now we just need to find the k. Well, if you input 1, we'll see what the output is. It's 1 minus 2 minus 8. So if we simplify 1 minus 2 minus 8, we are going to get -9. Now that we have a, h, and k, we can plug it all into our vertex form. So y equals a parentheses x minus h squared, and then k is at the end. You don't have to write the 1 in front, but you can write the 1 in front. All right, next, try that example on your own. Okay, last part of the video, we're gonna compare quadratic functions in different forms. So We're going to run out of time with this video, but try both of these based on the conversations before. Good luck.